So I want to avoid math, so I will start with something light again to get a break from being. So what I'm doing now is try to understand the implementation of a STWO, which STWO, which is the implementation of a circle stack. From the documentation or videos I watched, I get that STWO basically have three kind of breakthrough points or something special compared to other projects. And the first thing is, of course, they are circle stack. And the second one is they use LogUp for lookup. And they also use GKR to optimize this LogUp thing. But I'm not going to go deep here. And then the third thing is they use this in engineer Rust themed. Yeah. This compared to CPU, which I think people are more familiar with. SMD is something like a parallel computation thing. But I also want to explain more than that. So my intuition is, okay, STWO, it is a circle stack, it's a stack. So as an engineer, I just want to know how to use it. It is a prover. When I get a prover, how should I start to write a circuit? This is basically what I need. So I started to explore their code base. So as I said, what I need and what I have, I need witness, basically what is the trace I want to prove, what the properties. And then the second thing is I want to know my constraint. It's so urgent. So at this point, it's basically writing my circuit. And in Stark proof system, I will care about the boundary constraint, and then transition constraint. And there are also constraints between columns. Like this. So boundary is something like fx equal to 1, when x is the first element. I would like to use omega. And then transition is something like m omega x minus fx minus 1 equal to 0. This basically, I would want to prove if my trace, say, A is 1, 2, 3, 4, and B 1, 2, 3, 4 as well. What I want to prove is A is always incremental by 1. This is the transition constraint. And then constraint between columns is, let's see, this is the first column. And the second column, interpolated to polynomial f2. So f1 is my trace A, f2 is my trace B. So this is what I want to do. And I started to looking at the API in STWO and just try to find something straightforward to define these three types of constraint. So I found the API for constraint between columns. This is something called next interaction mask. And it needs two parameters. The first one, interaction, I still don't know what it does. But this one is called offset. And when I want to create a new column, I call this function with parameter 0 and 0. This is create new columns. And if I want to define the constraint between columns, I just call this function 2 times. I create 2 columns, and then I limit it to like column 1 equal to column 2. Now I defined my constraint between columns. And then next thing I want to define is my constraint between rows. This is basically the transition constraint. And I don't know if someone familiar with Hello 2 or Plonky 3. This constraint is very straightforward in these 2 code base. You just call a function next, which means you get the next row, and then you define a constraint between the next row and the current row. And in Plonky 3, something like slice row. It also means I just get the next row and do a constraint with the current row. So I want to find something similar in STWO as well. And I suspect it is still this function, but I just changed the offset parameter. It's kind of a straightforward offset, like the offset of your row. So I want to try something like 0 and 1, and it will return two things to me. And the first one is the column, on the current row, and the next one is the element in this column, the next row. This is my I thought it should be like this, but it just doesn't work. And I talked with a developer in STWO, and I just asked how you define the column between rows. And then they told me I should use lookup. So that at this point is already very confusing because it's a Stark, and in Stark you don't have a transition constraint, but you use LogUp to define the constraint between rows. It's quite not intuitive for me, so I feel I want to still try to verify this is not the case, and they should have something straightforward to define the transition constraint. So I start to dig more about these functions and just to try what's wrong with this method. And then let's go back to the conclusion first. So at the end, I realized in STWO, if you want to define the constraint between rows, you really need to use LogUp. But that's the thing I won't touch. But now I'm going to tell like what happened in here. This thing, it's something trivial fact that in Stark, but I just realized it's interesting for me, but it might be just trivial fact. When I start to dig more in this function, let me get some more background. I have a trace. When we get Stark, I have a trace I want to prove. And then the next thing I do is I do this. This is the evaluation on the trace evaluation domain. You basically get your polynomial from the trace. Your trace is the evaluation representation of your polynomial. And now I need to get the trace polynomial from the trace evaluation domain. And then the next thing is I need to expand this domain to get an evaluation domain. Use the blow up factor. So if my trace is like this, I have 4 points, and then trace evaluation also have 4 points. And then if my blow up factor is 2, now here it's become 8. And the requirement here from this trace evaluation domain to evaluation domain, it needs to be disjoint. So here you move to a coset of domain 8. Yeah. So Let me think how to explain more. And at some point, I realized this function started to do a sanity check, basically to check if to check the polynomial evaluations on this domain. What this means is when a prover, it gets witness from a user, it will do a sanity check at the beginning, just to make sure that the user puts the right input at the beginning. This done in Plonky 3, and STWO also do something similar. Like if I define my constraint need to satisfy this incremental by 1, I will check if before I put all the traces and the constraint into the Fry low degree test, I check if a user give me actually the correct witness, it satisfies this property. And in Plonky 3, this sanity check is done in this trace evaluation domain. But in STWO, I find this function, it starts to do sanity check on this domain. So the question is, does this transition constraint satisfy in this domain? Any intuition? It's no. Why?
Because blow up, whatever you blow up in between is not correct. There is some
I think the main point is this thing. This omega here means the generator of this trace domain. And when you move this constraint to a new domain, the generator in this domain is not omega. It should be omega. Yeah. So something changed here. So this constraint won't satisfy. And so in STWO, if they do the sanity check on this domain, of course it will fail. But that means basically my assumption is wrong. They definitely are not using this thing for the next call. But I just feel it's interesting here. So this constraint doesn't satisfy in this evaluation domain. Then why this constraint still satisfy? This actually satisfy in this domain. Yeah, it is because this defines the constraint between two different columns, and it's kind of the constraint just apply on its coefficients. There is no omega involved, so it's this constraint still satisfy in this evaluation domain. That means they only use this thing for columns, not using it for the trace, one trace alone. Yeah. So I can get a little bit more. So I reached this step, then I started to check in the evaluation of a trace in the circle domain. What's the representative, how it looks like. So I want to just first share how in STWO it represents a circle domain. A circle domain is something like this. This is what I watched from talks. This is correct? Twinkle set. Yeah. Yes. And then I want to have my trace here. Evaluate my trace to be the evaluation of a polynomial in this domain. And then how do they represent this domain? They use called half coset. And it has point index Yeah, point index, yeah, step. And the step here is corresponding to this omega here, but it's actually omega, it should be like this. I just want to compare to the normal Stark. When we talk about the multiplicative group, the normal one, like this thing, the step here is intuitively to be just omega. But when we talk about step in the twinkle set, it actually should be one size smaller. Because you need 2 to make, if I need 4 point, I need this size to be 4, that means this one size is 2. And the generator in this group will be one size smaller, supposed to be. Yeah, so I think I will stop here. Just, my exploration haven't stopped, so that's where I am. Thank you.